Hi, we're going to play the chaos game, and it's not really a game, but it is a structure that we want to set up and then see what kind of chaos, and when we have chaos, what does it turn into as we go along. And so eventually we're going to build a spreadsheet for all this, but we got to give you some background information first. If you just want to go to the spreadsheet, forward ahead a little bit, but I want to do the background first. So the game is to start with 3 points of a triangle. And then what you want to do is plant a random point within the triangle. And then we're going to assign one of the points, a 1 and a 2. And so we're going to roll a die and see which one we're going to select. So if we get a 1 and a 2, we're going to get an A. 3 or 4, we're going to get a B. 5 or 6, we're going to get a C. So we're selecting one of those points, A, B, or C, at random. And then when we roll the die, we're going to plot a new point that is 1/2 the distance from your random point to the vertex that corresponds with the roll of your die. So we're going to be attracted to either A, B, or C, depending upon what number you roll for the die. And then we're going to repeat this process over and over again. So whenever I get a new point, I'm going to be attracted to one of these other vertices again. So here's my setup: A, B, C, 3 points of the triangle. I have a coordinate axes system that you don't see, but I put values for points for each one of these, A, B, and C. And here's my random point. I'm going to put it right here. This is probably about halfway here and then halfway up, but it could be anywhere inside this triangle that we can start off with, and I'm going to label it X0. So we're going to roll a die to see which point we're going to be attracted to. Remember, 1 and 2 for A, 3 and 4 for B, and 5 and 6 for C. And I roll the die, and there it is. I get a 5. So when I get that 5, that means that I'm going to go to one of the points here. And in fact, it's going to be this point here. And I'm going to figure out what's halfway in between my random point and this C. And then I'm going to plot the point. So now I want to roll the die again and see this point. I'm going to say, okay, this point's going to get attracted there, there, or there, depending upon what I roll. So my next roll is a 3, and so I'm going to be attracted to the B up here. So I'm going to go halfway in between these, and let's see what we end up with. That would be this point right here. And so we're halfway in between these, so this distance is equal to this distance. That's my next number. Now let's do it again. We have this X2 right here. We're going to do this over and over again recursively. So then I'm going to roll a die again and see which one I'm attracted to. So I roll a 1. What does that mean I'm attracted to? Well, that means that I'm attracted to A in this case. So I'm going to go this way, and halfway in between would be right about there. So there's my last point, and I could keep on doing this forever, but I hope you got the idea of what's going on here. So this distance is equal to this distance. X3 is the midpoint of X2 and A, which is 0, 0. What we want to be able to see then is that if I continue this on in random fashion, is there a pattern that develops or not? From my chaos, does order come about? Well, I want to do this about 1,500 times to see if that order does come about. Do I want to do 1,500 times by hand? The answer is no. So we want to build a spreadsheet that will plot all these points for us and see what happens and what it looks like. So the intro to making the spreadsheet, we want to simulate rolling the dice for 3 points, midpoint calculation, if-then statements, and then also if-then nested statements. Those are the things you're going to need. So let's simulate rolling a die for the 3 points on the triangle, namely A, B, and C. The random function will generate a random number for us from 0 to 1. On the spreadsheet, you got to put a formula equal and rand, open parenthesis, close parenthesis. And what we'll end up with then is random number. If that rand returns a number that's between 0 and 1/3, we will use point A to be attracted to our next point. So this is the same thing as rolling a 1 or a 2 with a die. And then we go from 1/3 to 2/3, then B will be the attractant for our next point. And then finally 2/3 to 1, we'll use then C to attract our final point. So I just split up 0 to 1 into thirds because we have 3 points. Now for the midpoint calculation, I'm going to be on a coordinate plane, so I'm going to know the coordinates of each one of our points. But all you do is you average the x-coordinates, that will give you your x-coordinates, and average the y-coordinates, will give you your y-coordinate. And so when we do that, we're just going to be taking each one and our initial point, which we had x0, and then add x1, and then divide by 2. y0 plus y1 and divide by 2. Then when we do the next one, we're going to do, and this isn't exactly right because this would be the coordinates of point A, this would be the y coordinate of point A, or B or C, whatever it is. So these aren't the exact same x0, y0 that we had before. So what we want to do is find the midpoint for 0.255, which is approximately where I placed that original random point, and so it wasn't random. And then 1, 0, which would be the C point that we ended up with. So it's like this point, and I want to calculate this point here, which looks like it's x coordinates over 0.5, and then the y coordinate is less than a half, something like that. So for point C, I have 1 and 0, and then my initial point was 0.25 and 0.5. So I'm just going to average the x's, average the y's, and I'm going to end up with this right here. And that seemed like my estimate would fit whatever point I ended up with on for x1. So we're going to have if-then statements that we're going to be dealing with. I'm going to give you a simple example, and this isn't perfect, but if the random number is less than 1/3, then we'll be attracted to A with a midpoint formula, or else we'll do another calculation. So then we'll be attracted to B, or we'll be attracted to C. So when you set this up on the spreadsheet, you write equals to set off the formula, if, and then you need a parenthesis, open parenthesis here, and then A2 is where our random number is held, and we'll show you that in a little bit. But if A2, the random number, is less than 1/3, yeah, we're going to calculate the midpoint for point A, which is 0 and 0. Otherwise, we're going to do another point. And so this is how it's set up. Here's your condition. Here's what we'll do if it's true, and then here's what we'll do if it's false. This little parenthesis in here is, this comma here is not exactly right, but we'll get you going here in a second. So that is how we write if-then statements. Our problem, though, is that we want to deal with this 1/3, 2/3, and from 2/3 to 1. We got to deal with all of that so we can get attracted to A, B, and C whenever we get a random number that is in that category. So to write nested if-then, we're still going to use the premise that we had here for each one of our attractants. And you can think of the random number generator as being this little pointer. This is how it was explained to me many years ago. Pointer going up and down between 0 and 1, but so fast that all of a sudden when the computer says stop, it's going to generate a random number. And so this number would be between 2/3 and 1. And we want to see what's our outcome when it does fall between 2/3 and 1, or between 1/3 and 2/3, or between 0 and 1/3. So we can do this with what we call a nested if-then statement. So what we're going to do is kind of filter out and take out 1/3, anything less than 1/3, and then apply it to make an attractant towards A. Remember that the x-coordinate of A is 0. So that's what I put in there. And so this is, if this is true, then we're going to do this operation right here. Else, if it's not true, then we're going to go to the next step. Well, that's where you put another if then to say, okay, if we're less than 2/3 on our random number, then I'm going to apply this midpoint formula for the x-coordinates. Notice that this is the x-coordinate for the B point. And then also I'm going to have this one here, else, if it's not less than 1/3 and it's not less than 2/3, it's got to be between 2/3 and 1. And so it's going to apply this one here to attract towards C. So this is my A, this is my B, this is my C, x coordinates only. And if I want to do my y coordinates, it's this one in yellow. Notice that this is the y coordinate for A, y coordinate for B, and y coordinate for C, those points. So that's the nested if then. So let's use this little arrow and see what happens. So if I land right here, that's less than 1/3. So that means that if the random number is less than 1/3, then I'm going to apply this right here and this right here for my x-coordinate, y-coordinate respectively. And that is right because we're going to be attracted to A. Now what if it, and then it won't do anything else after that, it ignores the rest. What if it ends up here? Well, is it less than 1/3? The answer would be no. So it's going to go to the else statement. So it's going to say, is A2 less than 2/3? Well, the answer is yes, and so it's going to apply these for the x and y. See how this is working? I hope so. And then if it's up here, is it less than 1/3? Nope. So I'm going to skip this. Is it less than 2/3? Nope. So I'm going to skip this, and then else it's going to plot this, which would be an attractant towards point C. And I do have an error here because the point is 1, 0 for point C. So that's what I should have there for that point. So now let's make a spreadsheet. And we want to plot about 1,500 points of the chaos game and see what turns out. And then after that, we want you to make some extensions. One would be you use 5 points of a pentagon. Rewrite this whole thing. You have to manipulate and figure out yourself. And then also make up your own extension and see what you can come up with. But let's go to the spreadsheet. So for the spreadsheet, we just need some basic things. We need a random number. We're going to need an x-coordinate. And we're going to need a y-coordinate. And that's all we need. And we're going to plot the x, y coordinates on a graph. So rand, we said we're going to go equal rand, open parenthesis, close parenthesis. And then the x-coordinate, we're going to start off with, what did we say, 0.25. And we're going to start off with a y-coordinate of 0.5. And I didn't need the rand here, I need it here. So I'm going to go equal rand again, one cell down. Because now I'm going to take this number and then create these other two numbers based upon what we're being attracted to. Notice that this right now is above 2/3, and so it's going to be attracted to C. However, this will change as we keep on typing, so we can't hold to that. So this is where we're going to put our nested if-then statement. So if, and it's right here, A3 is the one that we're going to use, is less than 1/3, then we're going to go ahead and apply that midpoint formula. So I'm going to take the x-coordinate that I had here, and I'm going to add in my 0 because point A has an x-coordinate of 0. And yes, I want to type in the 0. Let's go do it. Okay, so then because if you want to modify this with different points, then you can just change that 0 to a cell name, and then we're in business. Don't forget to divide by 2. Else, we want to do another if-then statement that A3 is going to be less than 2/3. And then we can go ahead and apply the midpoint attractant to point B. So that's going to be B2. That's this coordinate is going to be added to, what's the x-coordinate of B? Well, that would be 0.5. And remember, we should have put parentheses here, and then we're going to divide it by 2. And then else, we're going to do the same thing. So I'm going to start off with the parentheses this time, B2 plus the x-coordinate of our point C, which is the 1, and then divide by 2. And then I need to wrap this up with the appropriate parentheses. Oh, they put the colors there. That's nice. So the black matches with the black. That should work for us. And that's the value we do end up with. Yours might be different, but it's based upon this random number that we do have. Now do the same thing for the y-coordinate, but change it to this as one of my starting values, and then the y-coordinates of point A, B, and C. So now I'm going to have C2 in here, and C2 and C2 instead of, what did we have? We had the other ones, but I need to change this to the new y-coordinate. So this one is still 0, and then the y-coordinate of point B is going to be 1, and then the y-coordinate of point C is going to be 0. I had that in there because that would show it up, and so there's the formula we do have. And then we can go ahead and hit enter, and we get these two values. Now to re-randomize this, you can go F9 usually, so function F9 can re-randomize those, and we're going to get changing values. And they're going to change depending upon which value we go after. Okay? And so you should be able to generate all those same numbers. Now all we have to do is take this and fill it down to 1500. So I grab the handlebar and there's the pattern that generates. I'm going to take this down to 1500 now and pause this. So I stopped about here because that's where it just took me. And then I want to go up to the top and make a chart. So I'm going to take these X and Y coordinates and I'm going to make a chart out of them. And we're going to make a scatter plot with that as well. So I'm going to highlight the X and Y coordinates. Don't grab the handlebar this time, but just grab these two cells and then, no, it's best to do that. Start at the upper left corner and go all the way down. You also can do some clicky things, first cell and last cell, I think with a shift. If you do first cell, last cell with a shift, then this also works, but this is how I'm doing it. So there I have it highlighted all the way to the bottom, and then I want to go ahead and insert a chart. And so I'm going to go over here and pick one of these. I'm going to pick the spreadsheet and just do the dots. Are you ready? Are you ready for this? Let's see what happens. Whoa! Look at that. That is amazing. If you know anything about this figure, it is called Sierpinski's triangle, and that's what it came out to be. There's some missing pieces. It probably could get locked in a little bit better if I did even more than 1,500 pieces. But that's what we end up with the chaos game. We can either highlight it and make it very colorful and pretty as well. That looks kind of Halloween-y. Wow, I hope that kind of knocked your socks off, that it would turn out like this. So some things you might want to do is extend it down further to see if you can fill it in a little bit more, or get these points tighter. I'm not sure how to do that. And work with this and extend it to 5 points. You make up 5 points on a grid and work with that, and then make your own extension after that. Chaos game. Look at what turned out. Woo! That's pretty fantastic. Well, I hope you enjoyed this. Have a great day.